some goats are voles, some elephants are voles, some voles are crows, and all crows are butterflies. And then there are 4 conclusions. As usual, our job is to find out which of these conclusions logically follow the given statements. Now, what do we do first? Draw the basic diagram for the given statements. So, the first statement here is some goats are voles. Some goats are voles. How do you draw this? This way. Some goats are voles. You can see that there's some overlapping between goats and voles. Then some elephants are voles. Some elephants are also voles. So, you can draw the elephants set in a manner where you get some overlapping between voles and elephants, right? Some elephants are voles. Then some voles are crows. Some voles are crows. So there's one more item here that overlaps with voles. Some voles are crows. So let's say crows are here, right? Some voles are crows. And the last statement says all crows are butterflies. All these crows are butterflies. So all these crows are butterflies. All right. So that's the diagram here. You see, some goats are voles. Some elephants are voles. Some voles are crows, right? There's an overlapping between voles and crows, and all crows are butterflies. All the crows here are butterflies. All right. So the basic diagram. Let us now look at the conclusions. The first one here: some elephants are goats. Some elephants are goats. Now you know the basic thumb rule, right? If a conclusion does not satisfy the basic diagram, what we have drawn here is called the basic diagram because it involves minimum overlapping, right? Minimum encroachment. So if a particular conclusion does not satisfy the basic diagram, you can straight away mark it as incorrect, right? A conclusion that does not satisfy the basic diagram does not follow the given statements. If it satisfies the basic diagram, then you'll have to check for the possible diagrams. All right. If it doesn't satisfy the basic diagram, it is incorrect. It does not follow. But if it satisfies the basic diagram, then you have to check the other possible diagrams before you mark it as correct. So with that as the concept, let's look at the first one. Some elephants are goats. Some elephants are goats. Now look at this. Elephants here and goats here. In the basic diagram itself, we find that elephants and goats do not overlap, right? There is no overlapping between elephants and goats. So some elephants are goats. Some elephants are goats does not follow. Why? It does not follow the basic diagram. Hence we can say it is incorrect, right? It does not follow the given statements. Second conclusion, some goats are crows. Again, the same argument, goats here and crows here. Is there any overlapping between goats and crows? No. Goats and crows do not overlap. So can we say some goats are crows? No, we cannot. This conclusion here, some goats are crows, does not satisfy the basic diagram. It is not following the basic diagram. And if a conclusion does not follow a basic diagram, we can say it does not follow the given statements. So some goats are crows is also wrong. Now the third conclusion, like I told you earlier, is something new. Some voles are voles. Some voles are voles. Now what do we do about it? Some A's are A's. Frankly, I have never come across a conclusion like this, right? It is like some A's are A's. Some A's are A's. Now, will this be true or false? Well, logically, if you see, I'm not sure if the conclusion is actually given that way. Only Ayub can confirm if it's present in the session here. But even if you assume it to be correct, some voles are voles, logically it follows. What do we have to check? Are some voles voles or not? Yes, I can choose some of the voles and always say yes, these voles are voles, these voles are voles, these voles are voles. You getting it? Some voles are voles. You can pick any portion of voles and say, see, these are voles. Is it going against the diagram? No. Some voles are voles. Yes, some voles are voles. Correct. So logically it looks like correct, but I would still like to check with Ayub if the conclusion was given exactly in this way, because this is not something that we see regularly, right? Some A's are A's. Some A's are A's. Logically it follows. I mean, from the diagram I can always choose some voles and say yes, these voles are voles. So let's go ahead with conclusion 3 as correct. Now look at the last one. Some voles are not elephants. Some voles are not elephants. Some voles are not elephants. You clearly see that as per the basic diagram, yes, some voles are not elephants. All these outside voles, all these voles which are outside elephants are considered as not elephants. So some voles are not elephants is correct. Correct according to the basic diagram. Some voles are voles is correct according to the basic diagram. But like I've told you, if a conclusion satisfies the basic diagram, then you have to check the possible diagrams as well. Now, why didn't we do that in the previous case? In the previous case also, the conclusion satisfied the basic diagram. Some voles are voles. But the point is, even if you draw 1,000 possible diagrams for the given statements, you'll always find that some voles are voles. You can always choose some portion of voles and say these are voles. Yes or no? So that is the reason we are not so worried about conclusion 3. But you have to be particular about conclusion 4 here. Some voles are not elephants. Some voles are not elephants. So according to this diagram, yes, some voles are not elephants, but will it always be true? No, it won't be true always. Let me draw a possible diagram to prove it wrong. How do we do that? Some goats are voles, so goats here and voles here. Some goats are voles. Some elephants are voles. Now look at second conclusion. Some elephants are voles. Can I draw elephants and voles in the same set? Can I represent both elephants and voles using the same set? I can. Yes or no? So look at the conclusions now. Some goats are voles. Yes, goats and voles overlap. And then some elephants are voles. You see, all these elephants are voles. Voles and elephants both are represented by the same circle. Nothing wrong about it. Now if you go back and check conclusion 4, what do you find? The conclusion 4 says some voles are not elephants. Tell me which wolf is not elephant? All the voles here are elephants. There is not even a single vole which is not elephant. So the point is, though conclusion 4 satisfies the basic diagram, it fails in the possible diagram. Conclusion 4 satisfies the basic diagram, but it fails in one of the possible diagrams, and hence it is false. And even otherwise, you should know, after you practice a good number of questions from syllogisms, you would realize that whenever the given statements are all positive, these are all positive statements. You see, some A's are B's, some A's are B's, some A's are B's, all A's are B's. These are all the statements here are in the form of either some A's are B's or all A's are B's. These are not negative, these are positive. What are negative statements? No A is B, no A is B, some A's are not B's. Those are negative statements. But here all the given statements are positive statements. So whenever the statements given are positive, the definite conclusion cannot be negative. That's a simple trick that you can remember. I would not like to teach this technique. I mean, I did not cover this directly in the video of syllogisms because this is something that you must not depend on. If you realize this after practicing some 30-40 questions, well and good. But don't take it as a shortcut and directly apply. Okay. All the statements are positive. So without worrying about possible diagram, I can say that some voles are not elephants would be a wrong conclusion because it would fail somewhere or the other, it would fail. Alright. So our answer to this question should be only 3 follows. Only 3 follows, which is some voles are voles. But I would still like to check this once and update you if there is any change I find. Some voles are voles. Logically looks like follows the given diagram, and it will follow all the diagrams. So the answer to this question finally would be only 3 follows. Only 3 follows.